Hi guys, welcome back to our data science tutorial. In today's episode, we are diving into the fascinating world of unsupervised learning. Unlike supervised learning, here we work with unlabeled data. We will uncover hidden patterns and relationship with the data using powerful algorithms like K-Means clustering, DBSCAN, and association rule learning. So let's get started. So the first question is what is supervised learning? Unsupervised learning is all about making sense of data without predefined labels. It's widely used for tasks like customer segmentation, anomaly detection, and market basket analysis. We will start with clustering algorithm followed by association rule learning. So let's go. So the first one is the K-mean clustering. K-means is a popular clustering algorithm. It groups data points into cluster based on their similarity. For example, in retail, it can help identify customer segments. So let's implement K-mean using Python. We will use a dataset with customer spending behavior. So importing necessary libraries. The first one is import numpy as np. The second one is import pandas as pd. The third one is from sklearn dot cluster import k-means. The fourth one is import matplotlib dot pyplot as plt. Okay, now creating sample data. So declare a variable data equal to parenthesis. Okay, so the first column is annual income. So the value is 15, 16, 17, 28, 29, 35, 45, 52, 54, 68. The second column is spending score. So the value is 39, 81, 6, 77, 40, 76, 35, 65, 29, 50. Now showing a data frame. So df equal to pd dot data frame. Now pass the variable data. Now run the code. Invalid syntax. We get an error. Import numpy. Predicting house prices using linear regression. Invalid syntax. Now visualizing the data. So plt dot scatter df annual income df spending score. Okay, now plt dot x label. What should be at the x label? Annual income. Now what should be at a y label? Spending score. Okay, so after spending scores, what should be the title? So plt dot title is the built-in function. So here we use customer data. Okay, now show the plot. Okay, so here you can see the customer data. Now after this we use the K-mean clustering. Applying K-mean clustering. So first we need to declare a variable K-mean equal to K means K should be capital. K means opening and close bracket, so number of clusters, which is 3. Okay, so random state should be 42. Now after this, here we use the column. It's a new column. So for this we use a cluster equal to kmean dot fit underscore predict. So for this we use df. Now again run. Okay, we got error and cluster. It should be clusters. S is missing. Okay, now after this visualizing cluster. Okay, so for this here we use a for loop. So for cluster in range 3, so declare a new variable underscore data, which is equal to df. Again use the df. The column name is cluster equal to cluster. Okay, now after this plt dot scatter cluster underscore data, use the column name, which is annual underscore income. Okay, now the next one is cluster underscore data. So spending score label equal to f cluster parenthesis, which is cluster. Okay, now after this, to show the table, to show the chart, plt dot what should be the label on x-axis. So annual income, plt dot y label spending score, plt dot title, k means clustering, plt dot legend. Now plt dot show. Okay, so here you can see the new chart after k-mean clustering, and here as you can see the legend. So cluster means there is a 3 groups: blue, orange and green. Okay, now the second one is the DBSCAN, which is a density based spatial clustering of application with noise. Unlike k-means, which requires you to predefine the number of clusters, so DBSCAN works by grouping point based on density. It's particularly useful for dataset with irregular shape and noise. Okay, so here we will discuss DBSCAN using the code. Okay, for this we use import our library from sklearn dot cluster import DBSCAN. Now after this applying DBSCAN, so declare a variable DBSCAN equal to DBSCAN EPS equal to 10 minimum sample, which is 2. Now after this create a new column, which is DBSCAN underscore cluster. so which is equal to DBSCAN dot fit underscore predict. Now df two-dimensional array. The first one is annual underscore income, and the second one is spending score. Okay, now after this visualizing the DBSCAN cluster. Okay, now for this we again use a for loop. So for cluster in np dot unique df db scan underscore cluster. Okay, now after this declare a variable cluster underscore data equal to df, again use df, the column name is db scan cluster, which is equal to cluster. Okay, now after this plt dot scatter, now pass the argument which is cluster underscore data. So the column name is annual income. Now after this cluster underscore data, the next column name is spending score. Now after this label equal to f cluster parenthesis cluster. Okay, now after this plt dot x label, on x label the title is annual income. Now on the y label the title is spending score. Now after this the chart title, which is a db scan clustering. Okay, now after this show the legend as well. Now after this plt dot show. Now run. Now here you can see the db scan clustering chart. Okay, now our next is association rule learning. Now let's explore association rule learning, a technique often used in market basket analysis to find a relationship between items. For example, customers who buy bread often buy butter. So we will use the a priori algorithm from the ML extend library to generate rules for a small data set. So for this, first we import our library. So from ML extend dot frequent erns, first pip install ML extend, run the code. Okay, so I have already installed the library. Now remove this one from ML extend dot frequent patterns import a priori association rules. Okay, now after this creating a data set. So for this we use the transactions, which is equal to pd dot data frame. Now the first column is bread, so its value is 1. Now the third one is the second one is butter, which is 1, milk, which is 1. Okay, now the second transaction is bread. Mm, I will copy this and paste it for the 3 times. 1, 2, 3. Okay, now change the values. 1, 0. After this 0, now 0. Okay, now after this applying a priori algorithm. A priori algorithm. So for this we use frequent ENT item sets, which is equal to APRIORIE. So the first argument is transactions. The second one is minimum support, which is equal to 0.5. The third column is use call names, which is equal to true. Okay, so after this generating association rules. So for this we declare a variable which is rules, association rules. Now frequent item sets. So metric equal to confidence. Okay, and the minimum threshold, min threshold, threshold equal to 0.7. Okay, the fourth argument is okay. Now after this print rules. Now run the code. Okay, we get an error. The fourth argument we missed, which is a number item sets. Number item sets equal to 4 because we have the 4 transactions: 1, 2, 3, and 4. You can also check the number of transactions using print len transactions. Now run. Now here you can see 4. So number of items are equal to 4. So our data frame is empty. So today we explored unsupervised learning techniques. We covered K-means clustering, this one, and the second one is DBSCAN, and the third one is association rule learning. So try these example on your own data sets and see the magic of unsupervised learning in action. So you will find the link of the this file in the description. So don't forget to like, share and subscribe for more tutorials. See you in the next episode.